The topic is limit. First of all, we have to know about the indeterminate forms. So the forms that cannot be determined are called indeterminate forms. For example, 0 by 0, infinity by infinity, infinity minus infinity, and so on. We also have to know that the answer of limit may not be an indeterminate forms, which means limit को answer कहिले पनि indeterminate forms मा निकाल्नु हुँदैन अथवा आउनु हुँदैन. यदि लिमिट को आन्सर indeterminate forms मा आयो भने के गर्ने त? So what happens when the answer of limit is in indeterminate forms? We have the 5 process or case we can do when the answer of limit will come in indeterminate form. So the first process is, or the first case is, do factorize if possible. So we have to factorize the question. The sample question is limit x tends to 2 x square minus 3x plus 2 upon x minus 2. Now let's solve this. Limit x tends to 2. Now let's factorize the numerator, where x square minus 2 plus 1 x plus 2 upon x minus 2, bracket close. Again, limit x tends to 2. Now let's open the bracket. X squared minus 2x minus 1x plus 2 upon x minus 2, bracket close. Again, limit x tends to 2. Now let's take common from both the terms. Now limit x tends to 2. Now taking common x minus 2 and x minus 1 upon x minus 2. Now we can cancel the x minus 2 and x minus 2 from the numerator and denominator. And we have now limit x tends to 2 x minus 1. Now we have to put the value of 2 in the x, and 2 minus 1 is 1. Now moving towards the second case, which is to apply the algebraic formula if possible. So we will apply the algebraic formula and solve the question in the second case. The question is limit x tends to 6 x square minus 36 upon x minus 6. Now let's solve this. Limit x tends to 6 and x square minus 6 square, which is 36, and which is in the form of a square minus b square. Now limit x tends to 6. The formula is a plus b in a minus b, where x plus 6 and x minus 6 upon x minus 6. Now we can cancel the numerator and denominator, and x plus 6 is left, where we put the value of x, which is 6 plus 6, and the answer is 12. Now moving forward to our third case, which is do divide the numerator and denominator by the highest degree or number of x, which means we have to solve the problem by dividing the numerator and denominator by the highest degree of x. Here the question is limit x tends to infinity 3x squared plus 4x plus 2 upon 5x squared plus 2x plus 1, which is in the form of infinity upon infinity. Now let's solve this. First of all, we have to divide the numerator and denominator by the highest degree of x, which is x squared. Limit x tends to infinity. Here we have to divide the numerator first with x squared and then denominator 5x squared plus 2x plus 1 upon x squared. Now let's solve this. Now we can cancel the x, and we have to write the remaining. Limit x tends to infinity 3 plus 4 upon x 2 upon x squared upon 5 plus 2 upon x plus 1 upon x squared. Now we have to put the value of x, which is infinity 3 plus 4 upon infinity plus 2 upon infinity square. As we all know that infinity square is equals to infinity. Since finite value upon infinity is equals to 0, so our final answer is 3 upon 5. Similarly, now doing the another question of the third case, which is in the infinity form. Solution: dividing the numerator and denominator by x, which is the highest degree. Let's solve this. Here in the numerator we are adding root under x square, as the numerator is in the form of under root. Now we can put together the both 5x square plus 8 upon x square, and the rest is denominator 7x plus 3 upon x. Now solve this. Here we can cancel the x, and the remaining is 5x plus 8 upon x square and 7 plus 3 upon x. Now putting the value of x, which is infinity, and we already know that infinity square is equals to infinity, and finite value upon infinity is always 0. So the final answer is root under 5 upon 7. Now moving towards our fourth case, which is to apply the theorem on limit. We have the formula of the theorem on limit, which is written as limit x tends to a x power n minus a power n upon x minus a, which means na n minus 1 is the formula. Now let's do the sample question related to the fourth case, which is limit x tends to a x to the power 5 minus a to the power 5 upon x minus a, which is in the 0 upon 0 form. Now putting the formula, and the answer is 5a to the power 4. Similarly, we are doing the next question of the fourth case. Here we are applying the algebraic formula, where 64 is in the form of 2 to the power 6, and here we can apply the formula of theorem on limit. And the final answer is 192. Finally, we are in our fifth case, which is also the last case. Here we have to rationalize and solve the problem. Here the question is limit x tends to 4 bracket x square minus 16 upon root under 3x plus 4 minus 4, which is in the 0 upon 0 form. Now let's solve this. First of all, we have to rationalize the denominator, which is under root 3x plus 4 minus 4. The rationalized form will be under root 3x plus 4 plus 4. After bringing it in the simplest form, we have to put the value of x, which is 4, and our final answer is 64 upon 3. Thank you for watching, and if you have any question, to comment it.